All right, here's a first example from our first lesson of 1-1 on points, lines, and planes. In this one, we're going to work on actually drawing. In this case, we have some points, we have some lines, and we have a plane that we all have to somehow draw onto this two-dimensional, in my case, the smartboard. Now, as I read through here, it wants us to draw a plane, R, which contains line AB and line DE, which intersect at point P. C is also contained in plane R, but is not collinear with line AB or line DE. Now, when you first read that, it sounds like there's a lot going on. So what I want to do is I just want to break this down into smaller pieces. I'm going to start here, and it tells us we have to draw plane R. So I'm going to think back to my lesson. Well, to draw a plane, I need to make this parallelogram shape. And now, so everybody knows the name of the plane, which is R, I need to put that scripted S, or R, excuse me, somewhere in a corner. And it doesn't matter. If you don't like it in that upper right corner, you could move it over here to the bottom right. I'm just going to leave it up here in the top right. Now, we also have to put in here line AB, and we're going to need line DE. So I'm going to go ahead and I'm going to make line AB. Well, if I have line AB, that must mean that there's point A and there's point B somewhere on this plane. And it's not specific where it's at, so that really doesn't matter. So I'm going to put line A there, and then I'm going to put line B right here. Being I want a line, just make my line to go through them, and to make sure that it's a line, put the arrows on the end. And then I'm going to make my line DE. And again, it doesn't really tell us where they have to be. So I'm going to put D here, and I'm going to put E here. So line point D, point D. And if you want to spread them out more, you can. Now, the reason I did it like this is because I move on a little bit farther, and I notice that it tells us they should intersect at point P. Well, as I make my line DE, it's going to intersect my blue line AB. And that's going to happen at point P. So I need to, I'll make that point there, and then I'm going to put the P. So far I have that first sentence taken care of. Now I go on, and now it tells us that we have point C here, and that one, let's use yellow. This might be a little tricky to see, but we'll see what happens. Point C is also contained in plane R, so it has to be somewhere inside of my green parallelogram, but it's not collinear with line AB or line D, meaning I can't put it anywhere on the red or the blue. So I'm just going to take that, put C right there. And again, probably not the best color. Hopefully you can see that, but it really wouldn't matter. I could put it here, I could put it here. That doesn't matter. As long as it's not on the red or the blue, I'm okay. I cannot put it here because now it would be collinear with line AB. So I'm just going to put point C right there, and I've taken care of everything that is involved in the description there. And I've made a three-dimensional, well, I guess this is just a two-dimensional picture on my piece of paper. Now my next one, this one's just kind of asking some questions based off of the diagram, and it wants to know how many planes are visible in the diagram. The first one's always easy. It's the big green plane. There's one. Now, you move on, and there's more planes involved, though. Some people look down here. We have point A, point C, and point B making another plane. What we have to realize is point A is on plane P, point C is on plane P, and so is point B on plane P. So this thing that I have colored in there as green is really not a different plane than the actual green plane that's shown. So far I'm at 1. Now I look here, and well, I can go with, if I take point D, point C, and point A and connect them, I get another plane. Now realize when I say connect, that probably wasn't the best way to say it, because remember, the plane's going to extend forever in all directions. Notice the little red triangle that I have highlighted. It's a triangle, and the plane would keep going, but we can see part of the plane in that triangle. So now I'm up to 2. I can also go on, and I can look at here, C, B, and then to D. Makes another triangle again, so that would represent part of a plane. Now I'm up to my third plane. And then last but not least, if I look A to B to D, this one that looks like it's in front, that would give me my fourth plane. The line over here to the left, that's not going to do anything as far as creating another plane. So answer to this first one would be, there are 4 planes. Now it says name 3 collinear points. Now remember, collinear has to be on the same line. So when I get there and I look at this, I got to find 3 points that are on the same line. Well, I could go F, E, but then there's not a third point on that line. You have point A and point B, that doesn't work. But when I get here, I can go B to G to D. Those 3 points are all on the same line. So my answer can be point D, point G, and point B. And the order wouldn't matter. If you're a person that likes to be in alphabetical order and you'd rather put that B in front, you could. I tried doing it, but they're all linked together. Name 4 non-collinear points. Well, you just have to find 4 points that are not on the same line. And really, you can start off with D, G, and B again. Those 3 together by themselves are collinear. Now, if I take a 4th point, and it really doesn't matter which one you pick, I could pick point A. Now, when I group the 4 together, since all 4 of them can't be on one line at the same time, they're non-collinear. And there are many more examples in that picture of it as well. And then my last question, it's asking, do line EF and line AB intersect? Let me get rid of that first, so I can highlight these 2. So I have line EF, which is this one, and then I have line AB. Make it a line so it extends. Now, based off of that, my picture that I have right there, it looks like they would actually intersect and they would touch. What you have to realize in this picture is, though, let me get rid of the blue for the time being. Notice you have this solid part of the line, I would say looks like it's above the plane, and then you have this dashed part, and the reason they make it dash is to show that it's actually extending through the plane. So it's not on the plane, it's just going through it. And I'd like to think of this as, think of the floor, and you'd have something vertical going through the floor, and then the red line is actually on the floor, but they're not actually going to touch, because where it looks like they're touching here, you know, if you're looking on the red, that's on the floor, but if you're looking at the blue, that would be below the floor. So obviously they can't be intersecting. So when we answer our question, do they intersect? The answer is no, they do not intersect, even though on this 2-dimensional sheet of paper it could look like they do. And those are the 2 examples that I'm going to give you from that first lesson.